kind of the next step in the process of learning about moles and percent composition is this piece right here called empirical formula. From your vocab terms, you guys should know empirical formula means the simplest formula. Okay? In other terms, it's really just simplest whole number ratio. Okay? Simplest whole number ratio. So I ask this question every year. What's a ratio? Don't tell me a fraction. Don't tell me division. You're absolutely right, guys. That's how we express a ratio. But in more generic or general terms, what is a ratio? Like at its root, all right, what is a ratio? One word is all you need to answer that question, by the way.
Fraction.
I just said no, don't say fraction. It is a fraction. I mean, like, again, you're absolutely right, guys, when you say that. But more simply, what is a ratio? What do you mean by a part? Okay, a piece of something. You're on the right track. What'd you say, Bryce? It's a comparison, guys. Absolutely. Now, it is a part. You're comparing one part to another. You are using a fraction mathematically, guys, and you're doing some division. But at the root, a ratio is just a comparison. You're taking one thing and comparing it to another thing. All right, and that's something that we're going to talk about. We're going to come back to all year long. So don't forget that, hey, a ratio just means a comparison. So in terms of an empirical formula, you're comparing in the simplest whole number way one element to another. How many elements, how many atoms of one element you have to another. It's the simplest formula possible. Okay. Now, by the end of the period today, we're also going to kind of get to molecular formulas, which we'll see how they're related to empirical in a little bit. But we're going to start with empirical. So why this stuff is important, guys, is this is how a lot of times unknown structures of substances are found out, is looking at empirical data. So when I was in grad school, we had this one instrument called a mass spectrometer. Really big, fancy, high-tech, very expensive piece of equipment. All right, and what we would do is we would take unknown samples. We did a lot of natural products research in the lab that I was working in. So they would take like plants and we would get extracts from them. We would try to get out certain chemicals to try to fight different viruses like MRSA. You guys have all heard of MRSA before? Staph infections, all right, not very fun, very dangerous things. So instead of using, synthetic means to fight it, using plants to fight it. So plants have a lot of different chemicals in them. So what we would do is we would get an extract out, we would then run it on this mass spec, and we would get a molecular formula, and we could get a basic structure, kind of a ratio of the elements. We had to figure out what the actual structure looked like if we wanted to, one, try to synthesize it, or two, to really kind of understand the chemistry of how it was affecting it. So that's kind of where this empirical stuff comes in. So there's a process. If you skip the process, guys, if you skip a step of it, it's going to be very, very confusing. Okay? But if you follow the process, and there's a little rhyme that's going to help you with that, they're really not bad. It's just one extra piece than what we've already done. So the first step, guys, you're going to assume 100% of the sample. You're going to change percent to grams. So you're going from, like it says in your notes, percent to mass. Okay. Maybe you want to highlight what's in bold or color it or circle it or whatever so that you know what that's going to be your saying. Number two, you're going to find moles from grams. We should know how to do that. We had a quiz on that yesterday going from grams to moles. So step number two, we go mass to moles. Okay. Step three, we're going to find the smallest whole number ratio, which again is just a comparison. We're going to divide by the smallest number of moles. So this is divide by small. All right, and then if necessary, the last step. So the last step is we times to whole. Now, this is something you may or may not have to do. Step 4, it's there sometimes, but not all the time. We'll get there and kind of talk about it. So the saying to help you remember this, guys, is percent to mass, mass to mole, divide by small times to whole. All right, it does rhyme, not like, every other line rhyming, but you get the idea. Remember that, memorize it, write it down. Okay? So one thing here, step 2 is, and step 3, actually, I'm sorry, step 3 is probably the most important. That's the one that people tend to forget the most, okay? Is dividing by the smallest number of moles. Because again, we're comparing. Now, you might be thinking, well, why even do we have to use moles? So we can't compare grams of one substance to grams of another. Why do you think that is? Why can't we compare grams of hydrogen to, say, grams of lead? Absolutely. They have different masses. Okay? They have a different mass. Why? What gives the mass of an element? Review for your test next week. Protons and neutrons. So guys, each element has a different number of protons and neutrons. So you might have one amount of a sample. Just because you have 5 grams of hydrogen and 5 grams of lead does not mean you have the same number of atoms. Hydrogen atoms are much, much, much smaller than atoms of lead. So it takes a whole lot more atoms of hydrogen to get that same 5 grams as it does 5 grams of lead. So we can't compare masses, we can only compare moles because, again, that's our counting unit. That kind of levels the playing field. All right? So that's why we have to go back to this divide by small piece here in step 3. And like I said, that's the most important step. If you skip steps, that's probably the one that you're going to end up skipping. Okay? Yet it's the most important. So here we go. Let's just jump into a problem here on the top of page 8 in your notes. Okay? So you're going to be given percentages. Okay? But again, like we've done everything, write down your given first. So I'm going to kind of separate it out. If you've been doing molar mass this way, you're kind of already used to it. Another reason why I try to get my students to do that with molar mass. So we've got 78% boron, and we've got 22% hydrogen. This next step is the most crucial step. All right, the hardest thing you're going to do right here. Do not blink. Do not, skip a beat here. Make sure you're paying attention. If I don't have your attention at all the rest of the year, this one step is the most important. Got it? Eyes glued to the screen. Here we go. To go from percent to mass is this very complex step like this. There you go. Little sarcasm there, all right? Who got scared? Me. All right? It's okay, yeah. That's. Did I? I went a little too hard on the hype there? All right, my apologies. I'll take that. I'll change that up next year. I tried to really get it this year. All right, guys, that's it. So if you're given a percentage, this is still the same percent if we think about it, right? They add up to 100 grams. It's still that same percentage of, hey, 78 grams out of 100 grams of boron is still 78% boron. Okay, that shouldn't make any sense. Now, if they already give you a certain amount of grams, you don't have to do that. You just go with what you have. Okay, but if they give you percent, most of the time you're going to be given percentages of elements. Change it to grams right away. So there's step 1, percent to mass. Now we got to go mass to moles. How do I go from grams to moles, guys? Nope. What'd you say? Yeah, we're going to divide. Divide by what? Yeah, molar mass, right? Set up your T-chart. 1 mole is how many grams of boron, and then grams of hydrogen on the bottom as well. How many grams do we have for boron? Get your periodic tables out. 10.81. And then hydrogen's molar mass is 1.008. If we round it, 3 decimals is more than enough. All right, do the math. How many moles of boron will we have? Now, don't round too soon, guys. Go to at least 3 decimals when you're doing this with your moles, because if you round too soon, it could mess up the next part. Okay, so carry 3 or 4 decimals here. This is where you definitely want to. So you said 7.216. We round, okay. And then hydrogen should be something like 21.825. All right, so there's steps 1 and 2. Okay, we've gone percent to mass, mass to mole. So the next step is, I'm going to copy my stuff right over here. So we had 7.216, and we had 21.825. Okay, so now step 3, the most important step, because we haven't compared anything yet, guys. All we've done is we've kind of leveled the playing field. Step 2 levels it, gets everything to moles, something we can compare to one another. So now we got to level the playing field and compare them to each other. All right? So this is where we're going to divide by the smallest number of moles. What's my smallest number there? All right, so I'm going to divide every number. Now in this case, I only have 2 elements. But I'm going to divide everything by that smallest number. Now, obviously the first one, boron, that's going to be 1. Okay? But the next one, what do you get for your answer for hydrogen? All right, so 3.024. For all intents and purposes, guys, what number really is that? 3. So if you're that close to the whole number, it's essentially the whole number, so 3. So now, what's my ratio here? If I'm going to try to compare boron to hydrogen, how many borons does it say that I have? All right, 1 to 3. Now, does that look like a chemical formula, though? No, that's not how we write a chemical formula. How would we write a chemical formula? I know we haven't done it officially, but you guys have experience with that. You know what formulas are. Like water's formula is what? H2O, right? So this formula would be BH3, right? Do I have to put a 1 there if it's just 1? Can I put a 1 there? You can, guys. You won't see it a lot of times, but same thing. I won't count it wrong. So our formula here for this was BH3. Notice, I didn't have to do step 4 in this problem. Step 4 is multiply to whole. Well, after we divided, we already had our ratio in essentially whole numbers. 3.02 is a whole number. Okay? We will see a special case here with another example problem when you have to multiply. Okay? So, we'll get there in a minute. Any questions about this process? Is it anything completely brand new, guys? No, it's taking steps we've already done, and we're just kind of putting it in a new order. Okay? So don't forget your basic chemistry. It's just an extension of what we've already done. All right? So we've done that. I kind of did that slide right here. So here we go. Example number 2. I want you guys to go through percent to mass, mass to moles. Okay? I want you guys to get these into moles right here, because you should know how to do that. That's a review from our quiz yesterday. Did I start with my percentages in my work? Does it matter, guys, that I just went right from percent to grams? No, because we know that that's what we're going to do anyway. So if you want to just write down your percentages, take them from percent to grams as your first step to save some space, go ahead and do that. Okay? So this is how you should set it up to go from grams to moles. Who can tell me how many moles of potassium we have in this problem? Somebody. What'd you say? 0.679 moles for potassium. How about chromium? And oxygen would be? 3716. 69. Okay. So what's my smallest number that I'm going to divide by? Yeah, the first one, 0.679. That's going to be 1. When I take 0.681 divided by 0.679, guys, what do you really get? That's going to be 1. But now the last one, when I do that, what do I get? Oh, so 3.49, which is kind of like 3.5. Now, this is where you have to use step 4. We've done percent to mass, mass to mole, divide by small. Now we've got a times to get to a whole number. The trap that people fall in right here, guys, is that they want to round a number like this. Now, we rounded 3.02 because, again, that is essentially 3. Okay? But when you get other numbers that are not that close to a whole number, you can't round. Why? Why can't we round this right here?
Because you round it up to 4 and then basically saying you have 1 more than oxygen.
Okay, so if you guys couldn't hear what Nick said, he said you'd round it up to 4, and that would basically be saying you have 1 more than you actually have. Remember, get back to the basics here, guys. What are we showing? We're showing a ratio, which is just a what? A comparison. So if I were to write this out as a ratio, where I have K to CR to O, okay, and then K is 1 to 1 to 3.5, and now if I were to round that to 4, is this the same ratio as I had before? No, okay, you've changed the ratio. But if I multiply it to get to a whole number, it's still the same ratio. What would I have to multiply 3.5 by to get to a whole number? 2. Now, if I did that to this one, I also have to do it to what? I have to do it to the other 2. So 3.5 times 2 is 7. To keep that same ratio intact, I have to multiply every element by that same thing. Because, guys, a 2 to 2 to 7 ratio is the same as a 1 to 1 to 3.5. You with me? Okay. All I've done is double it. But a 1 to 1 to 4 is not the same as a 2 to 2 to 7. So now my formula for this compound is going to be what?
A2CR2.
Absolutely. There's my formula. So a quick trick, okay, I did it all in one. Here we go, guys. If you end up with, after dividing by moles, that's the key. After you've leveled the playing field and got everything divided by moles, if you end up with 0.25 or 0.75, you'll multiply every number by 4. If you end up with 0.33 or 0.66, you'll multiply everything by 3 to get to a whole number. 0.5, you're going to multiply by 2. Chances are, in this class, most of the time, what you would see, guys, if you have to do this, is this last one where you're going to have to multiply it by 2. Now, you could see something else. All right? I don't anticipate you seeing something other than 0.5, but just be aware of it. But again, multiplying is the last step. It's percent to mass, mass to moles, divide by small, times to whole. What I see students who struggle with this and get confused, they want to multiply before they divide by moles. You can't do that. Otherwise, you're going to get weird decimals, and you're going to be multiplying by ridiculous numbers, okay? So just keep that in mind as you go through and you're working on it. All right? So, I want you guys to try the you-try problem on your own. Okay, so this is what it should look like. Now, don't just leave it like this. Eyes up here, guys. I know you're working ahead. That's great. Do not leave your final answer like this, though. That is not correct, and you will not get credit for it. You did all the work right, but you've got to rewrite the formula. Our formula for this example is going to be what? Ca3P2. Questions on that? If not, your homework is the rest of that page. Those other 4 problems, the you try and then those 3 at the bottom. You got the rest of class to work on it.